it earlier, E equal to negative dV by dr. Alright, suppose V, the potential is a function of x, y, z, defines the electric potential in a three-dimensional space. If you consider, see, electric field is a three-dimensional space. So if you take any point in the electric field, the potential at that point will be a function of x, y, and z. Then the partial derivative of this potential function with respect to x will represent the electric field intensity in the x direction. Now that is the meaning of E equal to dV by dr. You see, if we have an electric field in a region and you take a point R at a distance x from the origin, at a distance r from the origin, the electric field at this point is negative dV by dr. And you can express it using x components, y components, and z components. In other words, Ex is negative. Now, you see, some of you have some idea about what this is, but most of you don't understand this. Now, there is a difference between, let me show you that. There is a difference between dV by dx and del V by del x. You see, dV by dx is the straight derivative of V with respect to x. Suppose V is a function of x, y, and z. You see, potential at a point in an electric field is a function of x, y, and z. You read this quantity as del V by del x. And what does this quantity represent? This represents the rate of change of potential with respect to x when y and z are considered to be constant. It is called the partial derivative of v with respect to x. In the same way, the partial derivative of v with respect to y will be del v by del y. So I can have partial derivative del v by del y and del v by del z. So del v by del x is the derivative of v with respect to x when y and z are constant. Del v by del y is the derivative of the potential function v when x and z are constant. Del v by del z is the derivative of the potential function with respect to z when x and y are constants. So I can write alright. So I can now write Ex equal to negative del v by del x, Ey equal to negative del v by del y, and Ez equal to negative del v by del z. So the electric field in the x direction is negative of the derivative of the potential function in the x direction. The electric field in the y direction is negative of the derivative of the potential function in the y direction. And the electric field in the z direction is negative of the derivative of the potential function in the z direction. They are called the partial derivatives in the x, y, and z direction. We can combine all this and write a single equation for the potential function. This is the same as saying that the electric field in a region is the negative of the gradient of the potential function. Negative of the gradient What's the meaning of gradient? Well, derivative is the gradient. So, the electric field is a measure of negative of the gradient of the potential function. Now, in calculus, we can combine all these three and write an expression for the gradient. The gradient of a function in space is represented by the operator. Now look at that operator. We call that del. The operator del. And say del V. In other words, you use that operation on that V. Now what is that operation? That operation consists of finding the derivative of this with respect to x in the x direction, that is I. Then find the derivative of this in the y direction, that is j. And then find the derivative of that in the z direction, that is k. So del v equal to del v by del xi plus del v by del yj plus del v by del zk, and this represents a potential function in a three-dimensional electric field. Electric field in a three-dimensional space is given by E equal to negative, you can see, I don't think you can see my right hand side, E equal to negative dV over dr. Now this is the same thing. E equal to negative del V, negative of the gradient of the potential function. Electric field is a measure of the negative of the gradient of the potential function. Now let's do an example. Find the electric potential at a point 2, negative 3, 5 in space, where the electric potential is given by Vxyz equal to x squared plus y squared plus z squared. Well, Vx potential is a function of x, y and z. Now, if Vxyz equal to x squared plus y squared plus z squared, what is del V by del x? That's very simple for you. Find the derivative of V with respect to x when y and z are constants. That is what we call the partial derivative of V with respect to x. When y and z are constants, the derivative of y squared and z squared will be 0. So del V by del x is 2x. Alright, what is del V by del y? Will be 2y. When you want to take the derivative of V with respect to y, x and z will be constant. So del V by del y equal to 2. What is del V by del z? That will be 2z. And therefore, what is gradient of the potential function? Gradient of the potential function is del V by del xi plus del V by del yj plus del V by del zk. The gradient of the potential function has the x part, y part and z part. Well, that will be del V by del x is 2x, del V by del y is 2y, and del V by del z is 2z. That will be 2xi plus 2yj plus 2zk. And what is the value of this at this point, 2, negative 3, 5? Well, you got electric field E equal to negative del V. I want to make a small correction in the problem. The problem must read like this. Find the electric field at a point, not the electric potential. I gave you the potential function. I want you to find the electric field. So make that correction. Find the electric field at a point 2, negative 3, 5 where the potential function is given. Now, E, the electric field, is negative del V. It is the same equation that we used, E equal to negative dV over dr. And negative del V is negative 2xi plus 2yj plus 2zk. And let's now find the value of that at the given point. Now the value of the electric field at the point 2, negative 3, 5. Replace x by 2, y by negative 3, and z by 5. And that will give you negative of 2 times 2i plus 2 times negative 3j plus 2 times 5k. And that is negative 4i minus 6j plus 10k. In other words, what it tells you is, at this point, the electric field will be in such arbitrary direction so that its x component will be negative 4, y component will be negative 6, and z component will be 10 Newton per Coulomb. Now,